All right, so we are continuing 7.3 in case you wanted to catch up on any of these answers. That's fine. Hopefully you tried these on your own, but as I moved on to the next one, notice that we already have a y-axis reflection. And I don't want to talk about the x-axis yet, but what we have is a decay because we have a decreasing problem. And remember, we're using the clues that are given to you for your reason. You know, we can't say anything about the base yet because we don't know the base. All we know is the graph. So as your left end behavior, I want to see this as x goes to negative infinity. G of x, that's what this graph is named as, is going infinitely up. And then the right end behavior is as x goes to positive infinity. G of x, well, this time it's getting closer and closer to the horizontal asymptote, which is negative 1. So now this time the right end behavior is the equation of your asymptote, y equals negative 1, and that's your indicator for your c value. That c equals negative 1. Again, a quick reason, because the horizontal asymptote is at y equals negative 1. So let's talk about your a value. Notice that we're above the horizontal asymptote. So all we can deduce from this is that we have a positive a value. It could be 1, could be 12. I don't know. I'm just making up a number. Because the graph is above that horizontal asymptote. What that means then is that this is not a reflection over the x-axis. So that means that we have a decay function with exactly one reflection, the y-axis that we already established. Well, how do we get a decay when we have one reflection is if that base is larger than 1. That's how we can figure that out. All right. So if you have any questions, please write them down and bring them to me. Because as we look at the next one, this is not a y-axis reflection. It's a positive x value. So there's no reflection there. And so you might be looking at this next one, and you can already tell that there's no reflection at all. But before I do that, identify that we have a growth because we have an increasing function. And maybe you kind of jump ahead to what the b value would be if your brain thing is like this. Did I say base is greater than? Yep. The base is greater than 1 because as we're looking at this, there's no y-axis reflection. It's above the x-axis, so there's no x-axis reflection. So your reason for that is that you have growth with no reflections. And I mean, while I'm at it, I might as well even say that the a value must be positive because we're above the x-axis. And some of you might even look at this and say that it's pretty clear that the c value would be negative 2. I'm not sure why that got cut off. Because that's the equation of the horizontal asymptote. Y equals negative 2 because of the horizontal asymptote. At y equals negative 2. Now all you're left with is what's the left end behavior. Okay, well as x went to negative infinity, h, the name of this graph, is getting closer and closer to the horizontal asymptote of negative 2. And as x goes to positive infinity, infinitely to the right, h is also going infinitely up. So that's why they're both the same. So if you have any questions, please write them down. Bring them to class or email me, and we can set up a Google Meet and talk about things. So as we move on to the next one, I'm kind of tired of that graph, but notice in the directions, now they name it capital H of x, not like that matters. But you can see in the directions that we have a y-axis reflection. You can see that that's important. And while I'm looking at it, I know it's difficult, so I'm doing my best to get you to understand, is one end is going to be a ridiculously large number, and one end is going to be a number that's very, very close to, it's a decimal, but it's close to the horizontal asymptote equation. Every year I do this, somebody gets confused. And it could be flipped around because it depends on the reflections that we have going on. This could be a very, very large negative number. But as we read this graph from left to right, that's how we read things, it is decreasing. The numbers are going down. Well, if it's decreasing, then that implies that we have exponential decay. So as the left-end behavior goes, I think it's safe to say, based off of the clues in the problem, is x goes to negative infinity, h of x is going infinitely up. What about as x goes to the right? As x goes to positive infinity, this time I'm going to commit to that number being the horizontal asymptote. We're getting closer and closer to a horizontal asymptote of 1. So because of that, so this is influencing my horizontal asymptote, we can say that the horizontal asymptote will be y equals 1. And as far as the reason for this, I would just go back to the end behavior based on the end behavior. Or you could rewrite the end behavior that, you could rewrite this statement right here if you'd like to. So based off of these, and it might be helpful to draw the graph, and I'm not saying you have to, but for some people you just might want to see the graph. And I change colors. There we go. Is that we have this horizontal asymptote at y equals 1, and we could start plotting some points. Now, I would not expect you to count all the way up there. Negative 1 went up to 3, something like this. So you can see that it looks like it's exponential decay. And then it might help you identify, because A is above the x-axis, or sorry, because the graph is above the x-axis, that A value must be positive. Why did I say x-axis? It's above the horizontal asymptote. If you want a longer explanation, I can pull up the answer key. All the values are greater than 1. That's all the values are above the horizontal asymptote. It depends how much you want to write here. I can infer that you understood if you wrote all the values are above the horizontal asymptote, that you knew what you were talking about. And you could hit pause on the video and copy the rest of these down, but I'm going to explain the rest of it. So what do we have? We have a y-axis reflection here. We have a decay, and we're above the horizontal asymptote, so there's no x-axis reflection. So if we have decay, so I'll write down the reason first, with 1 reflection, that's telling me that that base must be greater than 1. Because that's the only way to have decay with 1 reflection is with a base that's larger than 1. So there's your reason, and there's your answer. And then your C value, kind of out of order here, but your C value matches the horizontal asymptote. C equals 1 because your horizontal asymptote is at y equals 1. And we haven't seen a domain or range problem yet. But as far as domain goes for exponential functions, is you can be any number for the exponent. That's okay. So the domain is all reals. The issue is your range. Well, the exponent never gives you a negative answer. So if you consider everything that we know, that's why we have a horizontal asymptote at y equals 0 on a normal day, but this time we're shifting up 1. Then it makes sense then that your range would be values for 1 all the way to infinity. Notice that we can never actually get 1. Another way to explain this is if you were to plot the graph like I did over here. Remember, we read the range from the bottom to the top. So when's the first y value that we get hit? Well, it doesn't quite touch at y equals 1. That's why this value is close to the horizontal asymptote. It's always above that. Now, pay close attention to the problem because sometimes the range is from negative infinity to one of those values if you're below the horizontal asymptote. But the domain is always all reals. Domain is always all reals for exponential functions. And you should be ready for the homework now.